final video on Unit 3. Yay! All right, our last stop point has got to do with monoclonal antibodies. They sound scary, but they're not. Yeah, I'm going to break them down. So what you need to understand about a monoclonal antibody is how we use them, or how, not how we use them, but how scientists and medical professionals use them to treat cancer. So there are quite a few applications of monoclonal antibodies that are coming out. And when we did the bit on melanoma, we actually did talk about monoclonal antibodies already. So we're just going to link back to that. So revising back to when we talked about cancer and when we talked about melanoma. So essentially it's a failure in apoptosis. So you've got a failure in apoptosis that happens, or resistance to apoptosis, maybe a mutation in the gene that controls it, and you get this multiplication of cells. Now, sometimes there are substances that can cause cancer, and these are called a carcinogen. Okay, so a carcinogen is the name of anything that can cause cancer. So that could be radiation exposure, either from the sun, it could be chemicals, it could be things like chemicals in toxins in cigarettes, things like that can cause damage to your DNA. Viruses can also cause damage to your DNA and end up giving you an increased chance of getting cancer. But essentially, you've got these carcinogens that end up with this abnormal gene expression, and you don't go through apoptosis when the cell needs to die. It becomes immortal, and they proliferate and multiply. So there are two words here, and there's another word that's not in the image. These are these words that you might come across, the word benign and the word malignant. So a benign tumour is just a tumour where the cells aren't cancerous, but they have multiplied. So you get this little growth, but it stays very controlled and it doesn't spread. A malignant tumour are the dangerous ones. These are the ones we talk about when we talk about cancer. And these are cancerous. They have the ability to break free. You can see that happening here, and spread to other tissues. Now, the other word that I don't have on here is the word metastasis. So when a cancer has metastasized, it's when these cells have gone and spread. Okay, spread of cancer cells to other parts of the body. It's quite dangerous, and when that happens, it indicates that the cancer cells have spread to your bloodstream, and therefore they can be almost anywhere in your body. And usually they cause secondary cancers. So you may have had someone in your family or someone that you've known that has contracted cancer, and they talk about a primary cancer and a secondary cancer. So a primary cancer is the site where the cancer first happens, and then a secondary cancer is one that's metastasized. So the cancer cells have passed into the bloodstream, traveled around, and ended up somewhere else in your body. So cancer's really disgusting and nasty and horrible. But we're coming up with all sorts of new ways to battle it. We don't know whether or not we're ever going to come up with one cure because there are so many different cells. But one of the ways that we need to look about is this immunotherapy. So immunotherapy is any treatment that harnesses the power of the immune system to fight diseases. Now, in particular, we're going to focus on cancer. So you can get these general immunotherapy things. These are the ones that you might take to just stimulate your immune system in general. So anything that might cause a production of more white blood cells. But in particular, we're going to be talking about a specific type of immunotherapy, and that is the use of monoclonal antibodies. Let's have a look at the history of cancer therapies. So traditional cancer therapies are things like radiotherapy and chemotherapy. Chemo meaning chemicals, meaning drugs. So you might inject horrible drugs into a person that go around, and these just kill any dividing cell. If you kill any dividing cell, you're going to be killing healthy cells in addition to killing cancerous cells. Yeah, so the cancerous cells are dividing, and that's why we want to stop all dividing cells. But there are also healthy cells, like the ones that are producing your hair. And this is why you find people that contract cancer, or people that are diagnosed with cancer, lose their hair, because these cells are rapidly dividing to produce the keratin that makes up your hair. So when you inject someone with chemotherapy drugs, or you subject them to radiotherapy, they will kill off the cells that are in your hair, and therefore you're likely to lose your hearing. Now, the benefit about these monoclonal antibodies is that now we're going to unlock the power of your own immune system, and you can see it just selectively kills the cancerous cells. Really great, right? Really, really great. So let's talk about these monoclonal antibodies. So monoclonal antibodies have this therapy, and we're going to abbreviate it into MABs, particularly when you're writing it a lot. If you write monoclonal antibodies and then in brackets you write MABs, you can use it from there, but don't use that just on its own. It's just an abbreviation to help us while we're writing these notes. So we should be on the page that's after your giant mind map, or the picture that we've gone through about the malfunctions of the immune system. And we're going to be looking at how are MABs used to treat cancer. So your monoclonal antibodies are antibodies that are produced by a single clone of a B lymphocyte. This is in your notes, but you might want to highlight the fact that it is a single clone of a B lymphocyte. So only one type of B lymphocyte. That's why they're called monoclonal. Yeah, one clone. And you get large volumes of the same clone. So they are all identical and specific to the same antigen. That's why this is so much better than your traditional cancer therapies, because they can selectively kill the cancerous cells. So let's have a look at how they're used to treat cancer. So you artificially manufacture them, and I will be going through that, but you don't need to know details. So no details needed. And they're injected into the body. What happens is they come along and they bind to a specific cancer cell antigen for that person. Now they function and they flag them for destruction. So now your immune system goes, oh, look, there's an antibody bound to that cell. What am I going to do? Yep, flag for destruction by a good old phagocyte. It's going to come along and start chomping away at your cancer cells. Now the healthy cells, which don't have the cancer antigens, don't get affected. This is harnessing the power of your immune system to kill off the cancer cells. Now, this bit here, which I think is on page 18 for you, can you write a big bit in there? So it's these steps where you have to draw them. But it's not on the study design, but it is a good application question. So this is how they make the monoclonal antibodies. They've made from these things called hybridomas. So the step one says that mice are injected with a particular antigen. So that's this one here. Step one, mice are injected with an antigen. Now the antigen induces these antibody forming cells. So these are the B plasma cells within the mouse to produce antibodies. So that's step two. Now what they do is they take out these B plasma cells and they add them to a tumour cell, because what do tumour cells like to do? They like to divide a lot, and they fuse them together. And this thing here is called a hybridoma. Okay, so this hybridoma that we've got here, this is now step 3 in your picture. Step 3 and 4, sorry. That step 3 is the merging of them. Step 4 is this hybridoma. Now what we can do is we can grow these on plates. So grow on plates. So agar plates agar plates. Yeah. And we get lots and lots and lots of monoclonal antibodies, and then we harvest these guys here. Step 5, harvest and inject. Okay? But this has to happen for every single person that has cancer. It is specific to every cancer. It's not necessarily a very cheap way of treating cancer, but it's a great way of treating cancer. There's another picture here for you to have a look at that goes through it. So what do we use these for? This bit here is definitely on the study design. You need to learn how we can do it. So we can do a couple of things. We can either put them in and they agglutinate and flag them to phagocytes. We've already mentioned that. You can also attach them to a cytotoxic T cell, which is going to come along and again attack them. So you can either use them to attract phagocytes or use them to bind to TC cells so that they come along and kill the cancer. And the last thing you can do is on the back of them, you can actually attach drugs or targeted chemotherapy. And so that's all kind of here. Here are some of the uses of them. You can see that here's the one that's got the TC cell attached on the back of it. You can see here's one that's got a toxin. You can see here's one that's got a cytokine on the back of it so that it will attract other phagocytes and cells. You can see other ones with different drugs. You can see here's another one with a liposome, which is another type of drug. You've got this one here. These ones have radioactive substances that are going to kill that tumor cell. So it's really, really cool to think of all the possibilities that we can do using these monoclonal antibodies. Now this last little bit, and feel free to stop the video, what we're finding is that they're useful for treatment, and this is off the study design, but they're also really useful in diagnosing where the cancer is. So here is a mouse that had cancer, and it got injected with fluorescently labeled monoclonal antibodies. So here's your monoclonal antibody, and on the back here, you put a radioactive tag. You put that into the mouse. These guys bind to the cancer cell and flag it, with this glow-in-the-dark monoclonal antibody. What this allows you to do under a UV light is you can see here is the primary tumor, but there are also these metastases. So these are little spread off cancers. Now, so little spread cancers all around the body. Very sad, but it allows you to identify how far a cancer has spread as well. So monoclonal antibody is useful in diagnosis in addition to cancer treatment. And we are officially finished Unit 3.